Nintendo Switch, let me show you what's going on. And we clearly have an issue. I count 3 bent pins. One is bent all the way around the plastic. If you can see that on the far right hand side. I would say 50-50 on whether it did any collateral damage. We'll find out. We're out of the housing and we're preparing to remove the port. In order to do that, I need to set up my equipment. And while I set up my equipment, let me throw my expected temperatures for this job up. These temperatures are brought to you by the Amazon Associate links in the description. If you head to my video description and click on one of these links and buy any of this equipment, or if you buy anything during that session, a small portion of that purchase will go to supporting the channel. And I'll greatly appreciate it. It won't cost you an extra dime. Flood our anchors with flux. We're going to flood in some material that'll change this high melting temperature solder into low melting temperature solder. When those pins wet and are ready to release, the port will drop off just like that. Nice clean pull, no copper pads stuck to the port. Excellent. We take a look at our pads and make sure that we have no bridge solder, and we do not, which means we can go forth with our testing. We'll begin our testing around the M92T36, and the first capacitor we're going to test is actually connected to the Pi 3 USB on the back of the board through the M92T36, and the line following the board we do not want shorted to ground is the line going to the M92T36, and it appears to be fine. Alright, let's test the other capacitors around the chip. Okay, this one appears to be shorted, so we appear to have a problem with the M92T36 at the very least. Another shorted one right here. Alright, let's check our CPU cap, make sure it is not shorted. Very good. Let's check around our MOSFETs. Sometimes when it's shorted where it is on the M92T36, you'll get shorts here. We do not have any here at this point. Check our filter. Filter's good. Let's check our invincible fuse. That never protects our M92T36. Now we're going to check our test pads. We should have no pathways to ground on these test pads. And we do. We have a pathway to ground. We know that is directly due to the M92T36. It's shorted all over the place. Let's check our big filter. We do not want to short to ground there, but we do want continuity through. And we do. Check our test pads. These should not be shorted. Now let's check around our BQ24193. We want no shorts here. And we have no shorts here. Excellent. Check around our Pi 3 USB. We're going to check this big capacitor first, and the line we do not want shorted to ground is the line going to the chip. And it appears to be fine. Now we're going to check our filters. We want continuity going through them from the chip to the port. We do not want continuity going side to side. And we do not generally want them shorted to ground. Very good. So I'm reasonably hopeful the Pi 3 USB has survived, but we won't know until we test that portion. But what we know for certain is we have a problem with this M92T36, and we are going to have to remove it from the board. We wet the solder, and we want that center pad wet, and we want to make sure it grabs the chip before we let go. Dry for a second, and then press down, not too hard. And done. That short is gone. And we don't have any shorts down here either. Let's test to make sure that one is gone as well. And no more short. Excellent. Check our work. Nice and aligned. Good, good, and good. And clean the pads with wick. Go with the pads. Don't go against them or cross them. Now with a ball solder on our tip, I'm just going to gently glide that ball over our pads. We're not trying to make contact with the iron itself, just the ball. Nice puffy pillows. Same concept on the port. Just want to run the ball of solder over the pins. Not really trying to make any contact with the iron. Excellent. Okay, I'm reasonably certain we're getting wetting now. Press down. And I'm going to keep holding down while I wait for evidence that our pads have dried. Let's check our outer pins. Sometimes when you're concentrating on getting that inner row down, you can neglect these guys. Not a big deal if you do, you can rework them. They're all solid and really nice fillets. Now applying a bowl of solder to our tip to get things started. Put a generous amount in these top two. These bottom two do not take quite as much. And pretty good feed through. Our next step is to clean the port thoroughly, clean the board thoroughly, and then we'll come back and do power tests. I hope this video is being helpful to you in your repair journey. Just a reminder, if this is something beyond what you want to try yourself, I do offer these services. Just head over to micromage.repair, click free quote, fill out the form, and I'll get back to you personally. We're clean and we're prepared to do some testing. So let's perform our first test with the PSU and our power dongle. And what we want to see here is a quick jump up in amperage and back down and no hanging. All right, that looks good. I want to see that on both sides. Excellent. Now using our modified iPhone power squid that we have retrofitted with Nintendo Switch and Nintendo Switch Lite connectors, we will activate using our OEM. Just real quick plug in and plug out. And what we want to see here is evidence that it is booting. Just a steady climb in amperage without any hanging. Let's grab our dock dongle and see if we're docking. And we are. That is excellent news. So our next step is to put it back in the housing and let it charge its own battery. And we will continue testing from there. We're back up and running on the Switch's battery. And as you can see, the fan is spinning. It is recognizing both Joy-Cons. Excellent. A little bit of travel on those Joy-Cons. And we're picking up our networks. Excellent. And Bluetooth is working. Excellent. Everything is working. And if you enjoyed this video, I think you'll enjoy this one right here. Click it and I'll see you there.